Okay, it's about 2:04. They start very soon, about minutes time. Right. Okay, let's start. It's 2:05 right now. Just let you know, okay, so we have about 13 of you here. The session is being recorded, so we will put it up later for if you want to go and watch it again lah. So today we are doing A-level 2024 paper, and then I will do the first three questions, and Mr. Tan will do the next three questions. So anyway, just to preempt, your both of us a bit sick, so if we go to coughing fit, please bear with us for a while. All right. You should be able to see my screen. You should see the PowerPoint window now. All right. So we're going to start with question one. So question one, you have a pseudocode given to you, and then it's to this set of operations to be performed on the ASCII values of each character in the word. Okay, then they give you this c equals 0 input I, while I is not equals to -1. Take an input number, and then sort if n larger than I, then c equals c plus 1, and if sort ni. Okay, so you're supposed to draw a flow chart to represent the operation. So swap should be shown as a single operation in your flow chart. Okay, so this one, this answer key that I took from is from the various JC teachers. We had a discussion at the start of the year lah. All right. So this is the flow chart that we came up with. Okay, so you take input, you set c equals 0 first, and then after you take input I. Okay, then well, if your input I is already equals to -1, right, then just output C. But if not, right, you take the next number. Okay, so you take one input first, then you take, if it's not equals -1, you take another input. Okay, then after that you compare is n larger than I or not. If it's larger than I, then you add one to C. All right. So because then after that, if no, then you just swap n and I first. Okay. Then after that, you come back to the same question as I equals -1 or not. All right. Then go on from there lah. Okay. So this is your flowchart. Okay. So one problem that the examiners highlighted for your flowchart is that the use of symbols, right? A lot of students do not know how to use the correct symbols for your flowchart. They have logical flow but do not use standard flowchart symbols, right? And then apparently the implementation of the if statements from line 5 to line 7 was more successful than the while implementation, lah, right? Some details. Okay, then after that, you're asked to, you are given, then they ask you to test, to do a trace table. Okay, so trace table, they ask you to test with hello. So ASCII code for the letters in the word hello are input into the program and are then terminated with -1. So ASCII codes are 72, 69, 76, 76, and 79. So that means when you feed in the input for this, right, you feed in 72, then 69, 76, 76, 79, you end off with -1. All right. So if you check the importance of -1, remember going back to here, right? Once you hit -1 for this one here, you know that your program will end. Okay. So we're going to fill up this table together. Right. Just give me, I'm going to put up my answer key as well. Okay. So we start off with C equals to 0, and then we put in our first input first. So we start at C equals to 0 first. See, I can make this a bit bigger. Hold on. Okay. Okay. Okay, so I start with c equals to 0. All right. Then again, then I take my first I. My first I, so the first number to be inputted is for I. So I becomes 72. So this is 72 first. Okay. Then that's all we have because now you will come inside here. You put I first, right? Okay. Then now you come to this while loop already. Okay. So you will take in the next input. The next input is 69. So my C has not changed. So I take in 72 still, this is 72. Now I take in my next input, right, which we're going for N, 69 over now, 69. Okay. Then do we need to update anything? So we check 72, 69. We are comparing whether N larger than I or not. So is N larger than I? In this case, N is more than I, right? So there's no need to update for this 0 here. This will stay as 0. So this is 0. Okay. Then once that is done, right, we will do a swap. Okay. So remember the next one is swap N and I. Okay. So you swap N and I, so this becomes 69. 69, and this becomes 72, and then this is still 0. Okay. Then after that, we will take in the next number, 76. Okay, so right now, this becomes 76. So 69 is still here, and then this is 76. Okay, then now we check, is N larger than I? So N 76 larger than I, right? So this becomes 1. Okay, so once this is done, we swap N and I now. So this becomes 76, and then this becomes 69. All right. Okay, so once I've done that, we can take in the next round of N, because remember, we will only terminate our code when I becomes -1. Okay, so now we take in, still this is still 76. Okay, then we take in the next one, which is also 76. Okay, because it's L ma, 76, all right? So 76 and 76, they are equal, so there's no need to increase for your C. C will stay as 1, and then you do a swap. Okay, so you do a swap, basically the next line stays the same lah. Okay, so we swap, all right? Okay, then now we take in the last one, which is 79. Okay, so this will still stay as 76, and then now we take in 79. Okay, 79 is bigger than 76, right? So now this C becomes 2. Okay, then after that we do a swap. Okay, so this is still 2. This will become 79, and then this will become 76. Okay, so we are right now here. Then now we terminate with -1. Okay, why many people are? Okay, we terminate -1, so this is 79. Okay, then we put here, this is -1. Okay, so we again compare, is N larger than I? If one is smaller than I, so we don't swap. So this stays as 2. And then now this guy becomes -1 because we swap N and I, right? So this becomes -1, and this becomes 79. Okay, and then this is 2. Okay, so now we have already reached I equals to -1. Once we reach I equals to -1, right, we can terminate and then we can output our C. Okay, so C will come to here and this will become 2. All right, so this is the output. Okay, so it's a bit complex, but I think you can trace along. Shouldn't be too difficult. Okay, I think this question is interesting because it's testing. You will look at the first two questions, right? It's testing you a lot on pseudocode and the basic understanding that we learned right at the start of our computing course lah. All right, I can go to presentation mode now. Okay. Okay. Ken, any questions so far? Screen share is on. Let me go back my screen share first. This one. Ken? Okay, okay, let's go on. Okay, next, we are doing, okay, what's the purpose of this operation? Okay, I counted some for you. So basically, if N is larger than I, then we increase C. Okay, so inside of H, right, then we take in E. E is smaller than H, so no change in my C. Then later we put in L. L is larger than E, so I update my C to 1 lah. Okay, then L no change. The second L no change. Then we're taking O, right, is also changing, so become 2. So basically, this is counting the number of times the preceding letter is smaller than the current letter lah. Okay, so I also highlighted some of the mark scheme, some of the examiner comments. So in terms of precision of language, right, we have to be very careful. So if you look at what was screenshot here, right, some weaker responses did not use precise language. For example, stating the algorithm counted the number of times that a letter was greater than the first letter. Okay, this is not the same as the number of times the letter was greater than the preceding letter. Okay, so you have to be very clear in terms of your word choice. Okay, so these are the things that I highlight. Okay, over the next few questions, I'll show you what distinguishes a stronger candidate and a weaker candidate. Okay. All right. Then next one, calculation, hexa 79 to hexa 79 to binary, no issue. Then explain one limitation of using ASCII as a method of encoding characters. So this is a 2-mark question lah. So 2 mark, you basically expect to write two things. Okay, so you need to say that either your ASCII is 128 deep or 256 characters, depending you go on 7-bit or 8-bit lah. And then after that, therefore you can only, you say that, oh, it can only represent English languages. Unable to support non-English languages when encoding. Okay, so if you look at the examiner's comments, right, some candidates did not expand on the points they made. Stronger responses explained that the number of characters that could be represented ASCII was limited. This meant that non-Latin characters could not be represented. So my take is that the second mark is not just about saying can only represent English characters. You will need to go on to say a bit more, oh, then therefore other languages are not represented as well. Okay. So far,
Can I interrupt here for a
yes,
while?
sorry.
Okay, now strictly speaking, ASCII is only 7-bit. Okay, 7-bit. The first bit, which has always been used as a 0. So
Mm,
effectively, there's only 128 character,
mm,
128 representations used in the ASCII. That is the exact one. But there are some literature that says, or you Google, you find that there are 256 using the 8-bit. That one is the extended ASCII, which is not internationally accepted. That means not everybody uses it. So it's safer to say that ASCII is just 7-bit, so 128. The other thing is that it's also wrong to think that ASCII only represent the English language, because within the 127 character itself, there are numbers, there are punctuation symbols, and there are also non-print key, like your return key, your escape key, your delete key, your backspace key. So there are other non-print key that is also within the ASCII 127 character. So yeah, if you just think that it is just English, then you are just talking about A to Z, capital letter, small letter. I think that
mm.
is a bit restrictive.
Yeah, so there's a more precise language here, lah. Okay, so before I go on, I also want to highlight to you some of the comments made by the examiner for the whole paper, right? Um, okay, handwriting and presentation of work were cause of concern in some cases, and some responses were illegible. Examiners were only able to award credit for work they could read. Weaker responses were not well structured and did not answer the question in a succinct and clear manner. Stronger responses clearly identified relevant points through clear paragraph structure using bullet points for their responses. Okay, so this is some. So we try to break the answer into paragraphs so that you know what's going on, lah. Right? Okay. Okay, now we come to question 2. Question 2, they give you a pseudocode again. Then you have this function. So you have n equals to 1, then return 12, else return s function sn minus 1 minus 3, then n if a function. Okay, so this is a trace tree diagram. Okay, I don't think we really taught this, but I think it's quite clear what you have to do this lah. So basically you call S2, right? Then S2 you will be under this condition over here, return Sn minus 1 minus 3, right? So you go to S1, S1 will give you 12, return 12, come back to S2, then S2 will return 12 minus 3 equals to 9. Then you return 9 over here. Okay. Use the above example to create a trace tree diagram for the recursive function call. Okay, so I did some animation now. I think just quick one, easier to see. Okay, so it starts with S5, right? So S5, you have to go down to S4. Okay, then for S4 again, you can't do anything. You keep on going down first. Okay, you keep on going down until you reach S1. Okay, then S1 from here, right? You can start to return the values. So S1 return you 12, right? So return 12. Then you take 12, you bring it back to S2, right? So these are your frames. Okay, you start from S5. You can't do anything there. You go into S4. Then you go to the next frame, S3, S2, S1. S1, you can return 12. Then you go back up again. Okay, S12, then the next few steps are just like that. Okay, at the end, right, you need to say that you're returning 0. Okay, so this is the last step that was coherent with whatever you have on the previous slide. Okay, over here. Okay, so there's a return, the final return here. All right. Okay, so this is what you have lah. This is what you're supposed to produce. Okay, then for this one, most candidates could produce an accurate trace tree diagram to show how call S5 will execute. Weaker responses often omitted the final return value of 0. All right. Okay. Next, recursion. Okay, recursion, 3 marks, so you expect to write 3 conditions. Okay, so it's defined. So how to show is recursive, right? Okay, so define in terms of itself. You make the same function call within itself, and then you have a smaller problem. So you go from Sn to go up to Sn minus 1. And then of course there's the terminating condition as well. Okay, so you look at the answer here, right? I try to, if they ask you to outline features of the function and the function is there, right? You have no excuse not to make specific references to the lines. Okay, and be very clear about what you are talking about lah. Okay, so again, also then they never talk about, you see, you never mention how candidates, you actually here also never say, because basically this is, I think the last point here, right? Fewer candidates articulate how each subsequent function call converge on the base case. That means eventually you reduce down to S to your base case lah. You go down there. Okay, weaker responses did not identify the context features of functions as that make it recursive. Right? Okay, so this
Allow
is
me to
fine.
interrupt here first.
Yes.
Okay, just now the trace tree, yeah. Now this trace tree is not the first time they came out in 2024. If you refer to the past year A-level question, recursion came out a couple of times, and this trace tree appear before. So you may want to take reference from there. Go and take a look at other past year paper, not just only the 2024. Second thing is about the Mr. Kwong just now the 3 conditions. Yes. Now for this kind of question, outline the features of a recursive function. There are 2 kind of marking scheme. One is a 3-mark marking scheme. One is a 1-mark marking scheme. I did come across before 1-mark marking scheme. So some students were wondering, wow, 1 mark, I got to write so many things, no? I need to write about calling itself. I need to say that it reduces smaller case or reduces a problem towards the base case, and then there's a terminating base case. Now, this is definitely a 3-mark situation. Now, if you think closely, if what happens if it's 1 mark, what are they exactly looking for? Now, then in that case, that recursion function need not be a successful recursion. That means it basically call itself. Within a function, there is a line that call the function itself. Itself is a recursion already. But then of course it is not successful because it will end up in a maybe a infinite loop or what, infinite depth kind of thing. But so in those situations where it is a 1-mark situation, of course you can give all these 3 conditions. Okay, but if you only want to give one, which I don't really suggest, if you think that 1 mark deserves 1 point, then it is the fact that within the function it calls itself that makes it recursion. Okay, because I come across a 1 mark A-level recursion question before.
Yeah, I can also write these 2 even if it's 1 mark.
Correct.
I
think
just write
we
one,
all
one.
should be kiasu and just write all the 3. Even if it's 1 mark, just give them 3. You won't go wrong.
Yeah. Okay. Can. Okay. Next one. Next one. I find one of the 3 questions I'm sharing. This is the hardest to explain lah. Okay. So I explain how a stack we use when S2 is called. Okay. So I try to I look at the answer. Then I try to make sense of it. I also ask ChatGPT for the answer and say, okay, the answer is correct. But it's not so easy to make sense of it. So I'll try. We see how well I understand or not. Okay, if not you just take it as it is. Okay, so we call S2, right? Okay, so this one, right, when we start off, we always start with a main first. When you run any Python code, Python program, there's a main first. Okay, so the slope represents my stack. Just imagine it to be that way. Okay, then what I do is that, okay, so once main comes in, right, main will call S2. Okay, so the function calls are on the side over here. Okay, so they're in that order. Okay, so I just put S2, then later on I just know, okay, because S2 I have to make one more call to S1 later, right? So I know that S2 later on I just need to return S1 minus 3, sorry, not S2 minus 3 to main. All right, so then this should be S1, not S2 minus 3. Okay, then I make the next one. Okay, so I take S1, then return S1 to S2. So whatever value S1 is later on, right, I will take it back and then give it back to S2. Okay, so right now I make 3 calls already. Okay, then what I do is that now S1 will return a value 12, right? So I push it into the stack as well. So this is what I get at the end, at this stage, 12, all right? Okay, then now I can start to go and open up things already. Okay, so what I do is that I'm going to, let's see, okay, I'm going to take out 12 first. I'm going to pop out 12 first. Okay, I'm just going to keep it there. Then I will pop out the next one, which is the S1 call. Okay, so S1 call will disappear. Okay, so because I go back up 1 frame already, right? Then this S12 will come to here. So, okay. So right now, I'm over here. Then what I do now is that I will pop out the next guy as to this orange box here. Okay, I pop it out. Okay. So okay, I'll call this 12 minus 3 equals 9 first, right? Then I remove this 2. Okay. Then now I'm left with main. So 9, right? I push it back into the stack first. Okay. So once I'm here, okay, 9 is here right now, right? Then again, I just take it out. Then I return 9. Okay, that's the base idea. Okay, so the explanation is a bit not easy, I feel. Okay, so basically when I call S2, right, so there's the one about this that's difficult is that you need to trace back which when you call one function, right? Okay, so return address the main program is pushed on the call stack. So that means the first item to go and say, okay, at the end of it, you need to go back to the main program. That's the idea of the first statement. Okay, then inside S2 function call S1, so return address to S2 and parameter n equals to push on stack. So again, this one, when I call S1, right, I need to say that, oh, S1 eventually return to S2. Okay, then so on and so forth lah. Okay, it comes down to this way. Okay, so difficulty in this for this question is that basically, right, you have, so the most candidates who understand the push and pop operations for the first in first out, but they could not identify what was pushed in or pop from the stack lah. Okay, then stronger responses identify clearly that stack frames will store the local variables and return address, so that control could be returned to the previous function call after the recursive call is terminated. So basically, you go back to this one here, right? This one over here. So there is always, it's clear that you see, you need to actually here, if you want to break it down, this one should be stored as different items. Okay, you call function call, then after you say, oh, after you get S1, you need to take the value and give it back to S2. You need to be able to return back down from. So you go from main, you push in main, you push in S2, you push in S1, then you push in the return of S1, right? Then from there you pop out 12, then you come to here, right? Then you need to return the value of S1 to S2. Okay, so need to go back down again. Okay, so this one is not easy to do. Okay, but I think in terms of the order, right, you'll be able to get the order right. But I think the difficulty is also stating clearly that you have to store the return address. Okay, this is the one that was mentioned inside the examiner's report. Okay, it took some time for me to
Okay.
explain this. Yeah, I think we
Allow
want to
me
add
to
on this one.
interrupt. Now, that's why I say that it's very important that you go through the 2020 A-level paper and 2021 A-level paper, because this question came out before. And in my suggested solution for one of this year, I can't remember whether is it 2020 or 2021, okay, the use of the stack to delay, I mean, for those function call that is not yet evaluated is being pushed into the stack. Similar to what Mr. Kwang showed you now, when S2 is called, put in the stack, line by line like this. In that particular year, the same question, the same solution has been given. So students, if they do not pay attention to what come out before in the past and how we should answer those questions, will fall into this problem. Like now we go through 2024, then 2025 come out the same question again. Again, you will find students don't know how to use this stack to explain a recursion call. Okay, so please, other than looking at 2024, please go and look at 2020 and 2021. The same question came out before.
Yeah, take some time to I would suggest for this question, right, you may want to draw it out. you really go and take a stack and then just go and draw it out. I think if you do on PowerPoint, it's easier to just drag and drop the squares. Okay, just to make sure that you know what's happening. Okay.
It is not
So
enough to know how the operation. You need
mm,
to know how to
yeah,
word it. You need to know how to write line by line, write it out
right.
to explain
Yeah.
to people how the stack actually works. What do you push in? What do you pop out? So that is the distinguish between a strong answer and a weak answer.
So, and this is a 4 mark question, right? And then they state clearly that when you call S2, okay, so you have to go into the full blown details. So you cannot just just escape out from this. Okay, next one. Explain to what happened to the recursion execution of this function that call S0 is made. Okay, so S0 is called for function of continuous call itself recursively since the base case will not be achieved. Okay, so this one, there was a weird line in the answer key. Originally they said it will lead to infinite loop. Okay, so why do you think I changed it to infinite recursion? Is there any so when do we use the phrasing finite loop? Anyone? You use infinite loop when you have your while loop, you don't have your proper terminating condition. Your while loop keeps on going, right? So that is in infinite loop. So the way recursion works is different. It's not a loop per se. You open up when you make a recursive call, you basically open up a new frame and then you go into more and more frames, right? Then you have an error. I think it goes something like in infinite frames or two something along the effect of too many frames. If you have made a mistake in recursive coding, you have seen it before lah. Okay, so again this one
Exceed maximum
maximum
depth
recursion frame or
recursion
something
depth.
yeah,
Yeah.
something like that. So that one is infinite, but that is a different error from your infinite loop error. Okay, so I think this one here you have to be very clear lah. Okay, so again, this is a 2 mark question. I think stronger response. So again, then run out of memory and terminate with a stack overflow error. Okay, so this is the stronger responses. Okay, so that means if you only write the first paragraph, you probably only get one mark. Okay, you need the second part to come in as well to get the full credit. Okay. So I think so far these first 2 questions not easy to do. But I think after that, question 3 becomes a bit better. All right. Okay, next we go to question 3. Oh, sorry. Rewrite the function. This one, no issue lah. Okay, so like I said, we said before, if you don't know how to write pseudocode, you write pseudocode that actually is like more or less Python code. That's fine lah. But I think not difficult to know the symbols. Okay, so remember in pseudocode we assign using this left pointing arrow. Okay, and then not equal is your this symbol over here. Okay, so you can check through this one. So basically is to just start from a result 12 and keep on decrease until 0. Okay, nothing much to add for this. All right.
Uh,
Okay, next. Yeah.
for D back to the just now the S0 weak answer says that when you put in the 0 it will not hit the base case. Okay, that is a very weak answer. That means they think the students just mentioned that it will not hit the base case, but things don't just stop there. You see, you don't hit the base case, then what happened? So the recursive call will call the -1, then call -2, -3, -4. That's where it end up as an infinite recursion, you see. So your answer should not just mention that it doesn't hit the base case. Besides not hitting the base case, what happened? There's a tons and a lot of things that happen behind the scene, okay, that leads to this infinite recursion. That distinguish between the 1 mark and the 2 marks answer.
Yeah. So 2 marks you have to give a bit more lah. All right. Okay, next one. Question 3 is an OOP question. So we have this. Okay, you realize this is quite similar to the one we set for prelim as well lah. You have bees. You have three bees. Then you have three types of bees. You have queen, workers, and drones. Queen store additional number of eggs, and then workers store nectar and pollen. And then they run one cycle at a time. The energy of the bee is calculated. Queen's bee energy decreases by 2, and so on and so forth, so on and so forth. Okay, if energy the bee has is less than equals 0, the bee status is set to inactive. Okay, draw a class diagram that shows the superclass, subclasses, inheritance, attributes, and appropriate methods. Note they never give you the name of the attributes to use. You can decide something that is appropriate lah. Okay, so some of you may say, oh, I want my attribute to be unique underscore identification number, or you just say UIN. That's fine. Okay, so I'm just going to show you this one. Okay, so the mark scheme that we came out with, all the teachers didn't have display lah, but I usually like to put a display class inside, because I feel that if you write a class, you have no way of displaying, right? Then what's the point lah, right? Okay, so I just store everything as UIN, status, gender, energy, then your get setter, get setter, get setter, get setter for each of them. Okay, so there's a standard get energy and set energy over here. Yeah, so from here, then I was looking at the queen and the worker class, right? So eggs, nectar, pollen, right? Okay, so technically you also can include get eggs and set eggs. Although in the question, right, they basically say that the number have already been initialized, number of eggs and then nectar and pollen. So it may not change lah. Okay, so it's not the most important thing here. But the most important thing here is that because the way the energy decreases is different for each of them. So that means the set energy, right, is different from the parent class. They should operate differently. The set energy, and set energy. So these three are the main things that you need to have lah. Because this set energy, right? They are basically inherited, but then you polymorph it to suit the use. Right. Okay, then other things to take note of is the directional arrow. Usually this one we try to draw it like a right angle arrows are not this way, but in PowerPoint I was lazy to go and do the angle one. Okay, and if possible, the ratio of the queen, the child class, does it have to be side or bottom? I think that's not so important as long as the arrows are actually not clear. All right, then make sure you have your minus and plus.
The arrow
Constructor
direction
also
is important. Arrow pointing
ah
from what to what?
correct. Arrow pointing from your child to your parent. But I'm saying that if
Yes.
you put it below, that's fine. That's okay. No issue. Yes. Then your minus and plus. I never put constructor also. Okay, so I think it depends on how much they want to give also. But of course you want to put constructor, that's fine. No issue. Let me just check. So common mistakes. Omitted one of the derived classes or drew the inheritance arrows in the wrong direction. Most candidates identified the attribute for each class and gave appropriate getter and setter method. So I think by this line, I should include the set eggs, get eggs, and set pollen, etc. lah. I think I should put that one inside as well. Okay, I'll go and update the answer key later. All right. Okay, next, moving on.
Priyans is asking whether should we indicate the type, the data type for each of the attributes.
You can lah, but I would think if there is mark for it, it's going to be minor.
Yeah, I think
And I
in the
think
based on from the
prelim
examiner report,
we
they
never mark also.
didn't mention about it.
Yeah.
So they didn't penalize students who did not put in the data type.
Because okay, the way we read examiner's report, I mean, you are not seeing it, but we also say basically when something is a problem, they will talk about the problem. So if let's say for example they say, oh, inheritance arrow is a problem, right? Then there's a problem lah. But then they never mention anything about the data types. So then the assumption, you can make one of two assumptions. One, everyone wrote the data type and therefore it's not a problem that you want to talk about. Two, very few people wrote, but to the examiner it's not important, so they never talk about it. So there's no way you can predict what's happening now, unless you go and poll everyone who took the paper last year. Okay, don't have. All right. Okay,
unlikely everyone put the data type. So
too much work. Too much work.
Yeah, too much work. And then so the examiner never talk about it, which means that it is not the important thing.
Okay, instantiation, creating object based on class definition when the object becomes an instance of that class. Okay, so this one, I never put the Oh, okay, I think I put next page. Okay, this one problem was weaker responses. Okay, instantiation was generally well understood, but there was a lack of precision in the use of language. Weaker responses mentioned creating an object or initializing an object, while stronger responses made it clear that the object created was an instance of a class. Okay, so you need to talk about the second point, even though it's 1 mark here. I think this is the full definition. All right. Okay, next, you are asked to explain explain encapsulation, inheritance, polymorphism using example. Okay, and they give 2 marks. So your example cannot be a shoddy example. Okay, so this one describe encapsulation basically is defining lah. Okay, and I think for those of you used to physics and chemistry, I think your like when you ask you to define terms, we clearly say define or state the meaning. That one is very clear. But in computing, I realized that they don't have that this kind of precision and language sometimes. Okay, so describe encapsulation using example. So encapsulation store. So you store attributes within the B class. Okay, access using predefined methods. So I state here, I'm talking about attributes like status and gender stored in the B class. Then if you want predefined methods, you can say, oh, get status, get gender. This is
Mr.
how
Guang,
you,
can I
yeah.
correct about encapsulation?
Mhm.
I hope these two line doesn't give the impression that the method is not within the B class. The attribute and the methods are actually kept within the object of
Mm.
the B class,
Within the class,
within the
predefined
class.
methods within the
Yeah.
class.
So
Mm.
the methods is not outside the object, That means once you create an instance of that B class object, the methods are all there already. You cannot change the method already. So encapsulation includes the encapsulation of the attributes and the method. All these are being kept together, encapsulated.
Mm. Okay. Then inheritance. Again, okay, I made mistake. I should use the word inherited lah. Okay. Okay, you can say basically the child classes is derived from the parent class. That's fine. And then they share common attributes like status and gender from B class. Okay. Polymorphism, same function, same method name, but different actions. Okay, so modified methods that act differently from the same method in the parent class. Okay, then give examples. Okay, I think here I will give at least two lah. Give two because okay, you give one right, it doesn't show the difference. You give two right, then you say oh, you give queen and worker or queen and drone and say oh they are same method name but they act differently. Okay. Okay, so then yeah,
Sorry,
these are here
allow
lah.
me to interrupt a little
Yeah.
bit. Just now the inherited, another way that you can use is the word acquire. That means the child class can acquire the attributes or the methods from the parents class. So that avoids the
Yeah,
use
don't
of the
use the
word
same word to
inherit.
define.
You don't want to say, oh, inheritance is about inheriting, the kind of you
Yeah, yeah.
acquire. So that's the one word that you can use. The
Mm,
other one about the polymorphism, the methods act differently. Uh, the child class act differently from the parents class. That is correct. That is polymorphism. Between the different children, the child classes, between the different child classes, like for example, the drone, the queen, the worker, even though they have the same method name, they also behave differently. So it is not just with the parent that they behave differently. Between them, among the child classes, they also behave differently.
yeah.
That can be called as a polymorphism.
Yeah, I think that's when you stating the examples clearly, then that will help to show that as well lah.
Definitely, yes.
Yeah. Okay. So yeah, so stronger responses included more detail, making it clear that the derived class method has a different implementation from the base class. Okay. Okay. Next, last one. You are asked to give the test data, normal, abnormal, extreme. Okay. So no. Okay. So basically, if you look at your nectar, right, nectar is between 1 to 20, 0 to 20 inclusive. Okay. So then you want to test with normal data. That means you test within the correct range, but not the extreme value. So the extreme value is 0 to 20 lah. So anything from 1 to 19, that's fine. Okay, abnormal will be outside of your range. That means when you take abnormal value test, it should fail. It should not be accepted. So as long as less than 0, less than the minimum value or larger than the maximum value. So you can give like -5, to 23, 24, doesn't matter. Okay, extreme is the extreme end of your normal scale, which is 0 or 20 in this case. Okay. Weaker responses as here. Weaker responses stated incorrectly the extreme data mean values that are very large or very small in general, such as 1000, instead of the range 0 to 20 given in that simulation. Okay, so this is again, if you got study this, you will know lah. You never go and study these terms, then you're gonna have issue lah. Okay. So I
Why
think
you
that's all
didn't
for
say 1000 for extreme? Because now if you put 1000 that belongs to abnormal.
yes.
Yeah, when we say extreme is the extreme end of the normal range.
We should still give you correct lah.
Which is you gave it correct. Yeah.
It's correct.
So it's the extreme end. That's why 0 or 20. These are the extreme end of the normal range. So that's the interpretation of what you mean by
Yes.
extreme.
Yes. Okay, can. I will stop my screen share, then Mr. Tan will take over. Give me sorry. That's my screen share. Stop share.
Do
Mr.
I
Tan, you
have
share. I
a
think I can give you right to try and see.
yes, I give a try again.
Uh,
Here. Okay.
can.
Can okay.
Hmm.
Okay, so question first I can't see my own. Okay, question 4. Okay, question 4 is a database question. So I'm not going to show you the diagram itself. The ER diagram, you should be able to draw it out. There are basically 4 attributes: the agent, the customer, and then this one is the property, and then you have the viewing. Okay, so main thing is that you need to indicate your one-to-many relation correctly. Okay, and that's for part 1. For part 2, the table description, uh, uh, most of all the attribute has been given. The thing that I want to highlight is the viewing table. The viewing table. Now you realize that in this viewing table, unlike for example, let's say agents table, customer table, and property table, there is this thing called property reference code, customer reference number, agent reference. This can be used as a primary key. Now, whereas for the viewing table, you realize that there's no such thing called viewing number. Like first case, second case, third case, first viewing, second viewing, third viewing, fourth viewing, that kind of thing. You don't have a viewing ID or reference number. So because of that, you need to make use of a few fields together to make it as a composite primary key. Okay, composite primary key. So the primary key for this composite primary key will be the property ID, okay, the property reference code, and the date of viewing and the time slot. Okay, down here I'm assuming that the at each viewing there could be only one customer viewing. Okay, every time where the agent bring the customer arrange a viewing on a particular date and time, there's only one viewing. That means one customer viewing. So that's why the primary key, the composite primary key, will be just the property, and then the date and time. Cannot? Okay. Can you see my slides? Are you able to see my slide?
Yeah, can see, can see.
Can, okay. So I just highlight the viewing. So it's property reference code and then the date and time as the primary key. The rest I put asterisk here because I can't do the underline. Those are the foreign key lah for the viewing table. Okay, part three involve the insert statement. Okay, insert statement. Okay, this is a very common mistake. Having a quotation marks around the field name. Now, where do you learn this from? When you use your DB browser and you try to create tables, DB browser will always use the open and close code. And then a lot of you just copy and paste. Now, I mentioned in class before, the reason why DB browser uses open and close code is because some of the reserved word, like for example, order, O-D-E-R. ODER is a reserved word for SQL query, where you ordered something, ascending order or descending order. So order cannot be used as a field name or a table name. So what happens is that when you use it, so DB browser overcomes it by putting a quotation marks to it. So by right, when we create, now this is highlighted in the examiner report. It's saying that erroneously place quotation marks around the field name, which means that Cambridge don't expect you to put quotation marks for your field name. Okay, so if you put quotation mark for your field name, Cambridge is going to take it as wrong. Okay, cannot. So please refrain from doing that. And your field name must be a single word. Okay, must be a single word. In the case where if you have telephone number, then you can use an underscore. Like for example, like the agent reference number. So underscore underscore. Or you use a camel cap also can. Okay, the other one is about the data type. I think too much Python. So students think that the text is string. Text and string can be used interchangeably, which is not correct. If you use string, it is wrong because SQL don't have string. SQL only use text or varchar, car or varchar. Okay, or you use text. So you cannot use string. Okay. So that's for question 4A. Question 4B. Okay, this thing about backup and archiving. Now, the question on backup and archiving is very common. If I were to refer to the this year other college prelim paper from NYJC, there's one answer that I don't quite agree with them. They say that we archive the data if we are not frequently using the data. Okay, that is incorrect. We archive data that we don't use anymore. Not because, it's less frequently used or seldom used, then we archive it. That is not correct. So long as all the data that is in operation, that means you need it in your day-to-day operation, you should only back up. So that in any case where there is an accidental deletion or corruption, you can quickly use your backup copy and restore the data and use it. Now, within all this data that you're using day to day, I take for example, there is this particular customer who never accessed the website for 1 whole year or 2 years, 3 years, never access. So this particular data is seldom used, less frequently used. Does it mean that you go and archive this data? The answer is no. All the data for all the customer, whether they seldom use or always use, you back it up. So that in terms of corruption or data deletions, you can recover it back using restore from the backup. So when do you archive? You archive when this data is 10 years ago. Nobody is going to look at it anymore. Okay, like for example, billings, people have already paid the bills. Okay, and these are 3 years ago, 5 years ago, or 10 years ago. All these bills, nobody is going to look at it already. So you archive this. Now, the reason why you want to archive is not archive and save in the same hard disk, because that defeats the purpose. Hard disks are expensive because when you run out of space, you got to buy new hard disks. So when you archive it, you actually take it out of the hard disk and put it into a cheaper medium, and store it somewhere else. so that it doesn't occupy your server hard disk space. Okay, so the two key point about archiving is that data that you don't need to use anymore, but you need to keep because of some legislative requirement or some rules and regulation that require you to keep the data for a certain period of time. Okay, so that one you don't use, but you need to keep. The other one is that you clear off the data so that you free up all your storage space. And all this storage space can be used for the day-to-day running or the actual operations on the database. Okay, I hope that clarified the idea of backup and archive. This is not a new questions. Okay, this question come out donkey times and many times. Okay, but then still there's this misconception or student miss out this idea, this part. Okay, so that is for question 4.
Okay, sorry, I just want to add something for the SQL statement. When you use, try not to use VARCHAR, VARCHAR. So because, okay, the difference between if you use a text type and VARCHAR, text technically the limit for the number of characters that can be entered is very high. Is I think 65,000 I think I is so basically a text type basically has essentially no limit. But VARCHAR, when you use it, right, you are supposed to state the number of characters you want to have. Okay, so when you want to use VARCHAR, when you know that, for example, your particular field, right, you only expect the table to that field to have, let's say, two characters. I say that you set VARCHAR to be 2, or you expect the user to enter like a date string for you, or you only enter like 1610222025. You expect only eight characters. Then you set VARCHAR to be 8. Okay, so if you don't want to worry so much about this, then in most cases, right, you can just use text. Okay, text. If you just remember the text, integer, and float, I think, text, no, not float, real, text. I think float works also. Text and integer, those are the main ones. Okay, so try not to, don't confuse yourself too much. Just stick to the basic types. Okay, yeah, that's all.
Yeah, okay. So okay, that's for question 4, database. Question 5 is a binary search tree. So then you are given the array. You are given an array, and then you have the left, right pointing to the indices of the element in the array itself. You have the root pointer, you have the next free, right? Next free pointer. Okay, so this question, drawing of the binary tree, this one I think should be quite easily done. And then two property of a binary search tree. Okay, so I think we all know that binary search tree has two left and right child. That's one. Then the left, later I give you the full wording. The left child, left subtree are all the elements that is smaller than the nodes, and on the right subtree, all the elements that is bigger than larger than the nodes, the element of the node. And then next one is to add in a new element into the array, and then change, redirect the pointer. So let me share with you the solutions for this part A. Okay, so this is the original tree where you populate it, right? I think you shouldn't make mistakes for this. I think this is a 2-mark thing. Quite easily earned. Okay, then next one, the wording for the binary search tree. Okay, so each node has at most two children, one left, one right. Why say at most? Because you can have only left leg, or without the right leg, or right leg without a left leg. Okay, so at most 2, so a left and right child. Every node in the tree, the left subtree contains nodes which is smaller, and the right subtree contains nodes which is greater. And then of course, if you go deeper and deeper within to the subtree itself, you realize that the same apply. The left subtree always contains nodes that is smaller than the nodes itself. Okay, then to add in a new element, right, Mandrick, then that is in index 6 because your next free is at 6. So I copy the original table. This is not the modified table. This is the original table so that the description, why I say this, the data value, okay, right, the data value at 6 will be updated. Okay, so data value at index 6 will be updated, and its left pointer will be changed to -1. Left and right pointer will be changed to -1. Wait first, left and right pointer will be right, and then the left pointer of index 2, right, New York, will change to 6. Now, how do you know this thing? You got to go back to your original this BST to put in the element itself. Okay, to put in the element itself. So it is MM is actually on the left side of New York. Okay, so the left leg of New York have to change to 6. Okay, so the index 2, the left leg, okay, the left pointer of index 2 have to change to 6. So that will point to the element that you have just added, and then the free pointer need to change to 7. Okay, so this one is okay. Now the next question is about the I'm referring to the question itself. Two problems that can arise using static data structure. Now, this static data structure, they are talking about a structure that has only fixed 10 nodes. Okay, so what are the limitations? Okay, first thing is that is of course uh, uh, the data structure is not expandable. You cannot increase the number of data to be included into it. Okay, and then there is also a waste of memory when the space allocated is not utilized. Okay, so that would be the two problem that arise using a static data structure. Okay, one is about the not able to expand. The other one is about the it has memory overhead when space allocated not utilized. That means you have 10 nodes, but then you only use 3 or 4. Okay, so those are the memory wastage. Now, this is not the case of a using a array for a linear queue, right? Where you delete you dequeue an element, then that memory space cannot be used. So this is not true, because the static data structure that is being can take up to 10 nodes, 10 values, can be used when you remove some elements from the tree. Okay, so this is being pointed out in the examiner report, that some students think that within a static data structure, the memory space cannot be reused. Okay, if it's being if the element is being deleted, so this is not correct. Okay, let me share back this question. Okay, the reverse in order traversal. Now, reverse in order traversal. So in order traversal will actually arrange the element in alphabetical order from smallest to biggest. But then a reverse in order traversal will arrange it in the opposite way, right? Okay, so from Z to A in that sense. Okay, so down here is the algorithm that is given, right? Follow the right pointer, recursive, repeat the steps, and also so forth. Okay, and then part 1 is to write that pseudocode and the reverse in order. Part 2 is to write out the elements. Okay, so even if you can't do part 1, you should be able to do part 2. Okay, don't miss that 1 mark. because you know, the fact that you understand that it's a reverse in order traversal already give you that 1 mark already. Okay, so here you have the Tokyo, Rome, Paris, New York, London, Beijing, right? From T to B. Okay. Now then the procedure is over here, right? If the right pointer, wait first, let's take a look, right? If the root pointer is not equal to -1, then recursively call itself, and then you leave it to you. We're gonna take a look at this. I didn't really look into detail about this code. Okay, I'll just leave it on for a while. Let me take a look. So if it's not left, right, then reverse call, go to the right output. Okay. So it is opposite of the it's opposite of an in order traversal. In order traversal will be the left pointer first, then the data value, then the right pointer. But in a reverse order, reverse in order, you realize that it is the right pointer first, then the data value, then the left. Okay, so if you were to compare this recursive program code with the one that we give you in our lesson material on the in order traversal, you will see that the line this within the if condition, the right pointer, this line, okay, the right pointer and the left pointer is upside down. That means reverse way. Okay, cannot. So because instead of the normal in order traversal where you have the left nodes right, now you have the right nodes left. Okay. So that is for the answer for 5C.
Yeah. Anyway, in case someone asks a quick question, can you reverse the list after you do in order? Not the best lah, but if you're desperate, then you just do it. If
Uh
suddenly you can't remember how to do this, then but you can remember in order, yeah. If no choice, can
oh,
right?
that is where was that the reason why a
Because
student asked this question before?
yeah. We always have cases like this where they ask, can they just reverse a list? But yeah lah,
Okay.
you desperate, you do it that way lah.
Okay. But please, if you use the, you see, because they ask for a recursive, functions, if you just use the array way of the, the substring, the steps and -1 steps, then it's not really correct. Yeah, like the start, stop, and then -1 to reverse the array, then it's definitely not correct. Okay, let's go on to question 6. I think that is the last question for this paper. So this is a talking about networking, client server architecture. Now, client server architecture, this question, if you refer to the past year A-level question, it came out before. Okay, so what is a client server architecture? That means you have a server. Now, some of you always fix your mind when you think server. Oh, it must be a file server. No. It's not only a file server. It can be a web server. It can be an application server. It can be a database server. It can be any server. It can be a server application server that hosts your Office 365. Okay, so it is a server. Now, then the client will log into this server. Now, for example, if I'm a web server, the client log into the server, make a request for a particular web page. Then the server will give that web page to the client, right? If this is a file server, a client log in and then download a file or upload a file. So the interaction, the request, and the response to the request by the server is done all in between the client and the server. Okay, so this is called a client server architecture. Okay, the server manages all the requests from the client, okay, and centrally. Okay, so that is the idea about client server architecture. I'll show you the answer later on. Intranet. Intranet. Uh, what's the difference between local area network and intranet? Okay, so yeah, we deal so much with local area network that suddenly this word intranets come in, it throw us into a spin. What is intranet? How is it different? Is intranet the same as local area? Now, local area network is where you connect client machines, you connect your host using a switch, and then you create a local area network. And then if you have another local area network, and then you want to communicate the two local area network, you use a router and you connect two local area network, and then they can communicate. Two LAN can talk to each other. So this is what we call the local area network. Now, whereas intranet is not that physical, connection of the 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 hardware. It is more like a logical kind of segmentation. That means within the local area network, there is this called finance department. And this finance department, the IP address and those kind of thing, only certain authorized person can access it. And that part is called the intranet. That means it is a restricted access within the network itself. Okay, so that is the purpose of setting up a intranet within your local area network. I hope that explained a little bit on the our understanding of the correct understanding of what intranet is. Okay, so I'm skip onto this. Okay, so local area network is a physical, geographical, local network. You connect up all the hosts using your wire, your switch, and those kind of thing. Whereas intranet is a logical access restricted network for the private restricted access. Only authorized user with the correct credential, right? The username, password, or token, okay, have the access right. Then they can log into this area, this intranet to retrieve or access the data. Okay, so intranet is a subset of a local area network, more for the purpose of restricted access. Can one step back, 6A, client architecture. Strong response, make it clear that client requests specific services from the server, and the server respond with required data for the given request. Okay, so that is the client server architecture. And then part C, uh, I think this is similar to our prelim questions, where we ask why is there a need for network protocol? Okay, network protocol, and this is a 2-mark thing. This is a 2-mark thing. So network protocol is a set of rules that helps to govern the for the different devices to communicate effectively. Okay or not? Okay. Now, it's a 2-mark thing. So in the context of the question, says that this is what? There's a SMTP protocol, and then there is a HTTPS protocol. Okay. And of course, you need to understand a little bit what do you mean by HTTPS protocol using for intranet access. Okay, this is not internet access. Don't always associate HTTPS protocol to be used with internet. SMTP is a small mail transmission protocol. So this is used with the mail server. Okay, sending of mails. POP3 is the one that receiving mail, but you don't have to go into that detail. So since SMTP and HTTPS is being mentioned in this question itself, it is only right that we talk about them in our answer. So for example, SMTP is used to send mail, ensuring proper format and delivery of the message. And HTTP provides a secure encrypted connections as accessing the company's intranet protect the data for unauthorized access. Okay, so 1 mark for each. Okay, otherwise, if your reason for using protocol and say, oh, it's just to make sure that different hardware, different software can communicate effectively, then you only get 1 mark. Okay, so go on and use the context as an example to answer this question. Let me take a look at the question. Okay, D and E. D and E. Now, if you answer D well, okay, D has to do with the digital signature. So let me point to the question again. Okay, so D talks about the purpose and also how digital signature is being generated. I think in our lesson material we have very detailed outline of how a digital signature is generated. Okay, now of course there are some misconception. Now as that digital signature will encrypt the whole message. No, digital signature doesn't encrypt the whole message. Okay, what actually happens is that you use the let me see. Okay, you use the sender's public key. Wait first. Okay. Okay. This sender, which is Alice. Alice uses her own private key. Her own private key to to encrypt. Okay, to encrypt the hash digest. Now, what is a hash digest? You take the message, okay, and hash it. The original message when you hash it. Now, once you hash the original message, this hash digest cannot be unhashed one. It's just a string of numbers, that's all. Okay, so this Alice will encrypt the hash digest. That means this string of number using her private key. And then that is called the digital signature. Okay, so I repeat again. Digital signature is the encryption of the hash digest using the sender's private key. Okay, now then the original message is not encrypted. Together with the digital signature and the original message is being sent to the receiver. Cannot. So now the receiver received the message. He doesn't know whether this message to trust this message or not. Okay, because you don't know this message has been altered or not altered. Okay, so the only way to do it is to hash this original message and compare with the hash value that Alice sent to him. If these two matches, then the original message is unaltered. Okay, but the problem is, how do this receiver get the original hash value, the hash digest, which Alice sent? Because Alice has already encrypted it. So the receiver must use the public key to decrypt the original hash so that he can get the hash value. And then, so he has Alice hash value, and then he used the original message and hash it, compare the two hash value. If they matches, correct. Okay, the message is not altered. Now, if this receiver have used this Alice public key and successfully decrypt the hash digest, then it also proves that the sender is actually Alice. So it does two things. Prove that the sender is really the correct sender. Prove that the document has not been altered. Okay, in all this whole process, the message is never encrypted. The message is never encrypted during the transmission. So this is something that you need to be careful with. When we use digital signature, it is wrong to think that the original message has been encrypted. If you still have that thoughts, please go through our lesson material, because our lesson material specifically point out that the message is not encrypted for transmission.
Okay.
Okay?
I was just looking at what Mr. Tai explained. I found it very familiar. I think we actually talked about it in class. So I shared the link for the cosmology package. Where we talk about the digital signature one. So it's a video there. You can go and watch again. And I think in class we did try to discuss this one. So just go through that one lah. All right.
Yeah. It is, you see, it's the impression, students' impression that I'm very worried of. You know, you learn that in lesson and all kind of thing, and then you keep thinking that digital signature encrypts the original data. This is totally wrong. Okay, digital signature doesn't encrypt the data. Okay, cannot. So please be careful with that. Now, I show you E because E will be the main thing, the litmus test, to know whether you know how to answer D or not. Okay, of course, just now I mentioned the purpose of the digital signature is to prove that the sender, okay, is to prove that the, let me see, where is it, uh strong senders, no, it, okay, where's the answer? Okay, is to prove the sender. That means the authenticity of the sender. That means the sender is the one who actually sent it. The other one is to prove that the document has not been altered. So this is the two purpose of the use of digital signature. That's for part one. Then the process of how you encrypt all this kind of thing. I mean, we can share these slides with you. Um, but then let's take a look at the E. This is the most important thing. You see, the question asks, uh, if intercept Alice transmitted and modified the document, how Bob will know? So on the receiving end, so this uh uh this document has been modified already, and Bob received Alice documents that has been intercepted and modified. Okay, let's take a look at the answer. Bob uses Alice's public key to decrypt the digital signature. Why he used Alice's public key? Because he believed that Alice is the one who sent. So he used the public key and then decrypt already. He get the original hash. The original hash. Now he can't make any meaning out of this original hash because it's just a bunch of number. That's all. Okay, there's no meaning to it one. Now Bob will create the new hash digest with the modified document. Now, if he use a modified document and create a new hash, definitely the two hashes will not match. Okay, the two hash will not match, and then Bob will know that the document has been altered already. Okay, cannot. So the mismatch in the hash digest alerted Bob that Alice's original document has been intercepted and modified. Can? So I think the 6E, whether you can understand and whether you can answer it, tells very much on whether you know your 6D part 2 or not. Okay? Cannot. Some candidate went on to state how the whole document could be encrypted with the receiver public key and so on and so forth. Now this is totally irrelevant. The whole purpose of using digital signature does not involve the encryption of the message itself. Can? I am done with all the up to question 6 already, Mr. Kwang.
Okay, I think we are done for today. Next week the session should be on, let's see, when is physics time trial? Physics time trial is on 23rd, I think. Correct? I think so. If I remember correctly, it's same as chemistry one day after their practical. So I think tentatively we will still have it on next
Next
Thursday.
Thursday.
Next
Next
Thursday,
Thursday.
but we're gonna put it a little bit later so that you have time to come home lah. Maybe instead of 2 to 4, we put it as 3 to 5.
Yeah.
Right. Then we will let you know what questions we want to discuss
Yeah.
over the weekend. Then you have a
Yeah.
bit of time to prepare for it.
For the
Okay.
time being, they can refer to the summary.
Mm.
The summary from what we did for the 2025 other college prelim
Mm.
paper. You take a look at it. Those things that have been highlighted are questions that are kind of not included in our prelim paper. So some of the topics, which I kind of highlight some of the words, some of the subtopics are in red. And then there are a few questions as a whole, quite interesting to look at. Those are highlighted in yellow are those that we must look at. Those are in blue are those that is interesting. If you got time, you can take a look at yourself. Okay, but please, for your revision, you may want to look at all the those topics that you're not familiar with, right? You look through the parts, and if come to you and say, oh, I don't know what's the answer for this, I don't know, well enough on this topic, then please go and read up, and then go and take a look. Okay, then next week will be a more productive kind of discussion.
Yeah, look at the A-level questions first lah. I think you bare minimum go through until it's 2021.
Yeah.
Then go and look at the JC prelim papers.
Yeah, I keep on stressing 2021, 2020, because these are the 2 years that we have gone through very detailed kind of answers there lah. Okay, based on the examiner's comment, because we attended the workshop by the Cambridge Marker, so they give us very good feedback.
Okay. Yeah, I think that's all. This period of time, I think the next exam you have is your physics prac, so go and prepare for it accordingly. Don't get too stressed about competing. I think we can have one more session the week after our prac. So that means one session coming week, the next Thursday, and maybe just expect one more around the same time as well, the Thursday after. So that would be 30th October, that period of time lah. We'll let you know again. Okay, I think otherwise, I think we are good. I just saw someone raise hand just now. Did someone raise hand? Anyone got any questions to ask?
Mr. Kong, I got a question.
Yeah.
For like the question 1D part 3, right? Like they say the extreme one limitation of using ASCII, right? Like then just now you say cannot say like ASCII can only represent English. Then like instead of saying like English, then what can I say?
I changed my wording slightly lah, because just now based on Mr. Tan's feedback. Give me I go and find my wording. I rewrote it as okay. So ASCII is restricted to 128 characters as is represented with 7 bits. So there's insufficient space to support other non-English languages. So I never say only support English. So that means I'm not saying it only support English. I'm saying that it cannot support other other non-English languages lah. Yeah, so that is a bit better lah.
Yeah.
Yeah.
Kai Chi, is it? Kai Chi?
Yeah.
The reason why I added just now to say that ASCII contain not only just English, because to be exact, it contains other things.
Punctuation,
Yeah,
written and
it
stuff.
contains other
Yeah.
things. But then Mr. Kwang is correct. After representing all the necessary key, the
Not enough space.
non-printed key and the English letter and the 12 and also the numeric, there isn't enough space for other language already. There's no space for other language already. So ASCII is too small a capacity lah. 128 representation only.
Yeah. Ken, anyone, anything else? Okay, Ken, if not, we call it a day today. Then I will put up the video later. So I think y'all can look at the video again. All right. Thank you.
I think it's a
Bye-bye.
tradition to turn on your mic and say thank you and say bye-bye.
Thank you. Bye. Thank you.
Bye,
Bye-bye.
guys.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Thank you. Bye-bye. Bye-bye. Okay. Mr. Tan, go and rest lah. I also want to go and do rest also already.
Can. So later on when later on then you upload lah. Upload then
Okay,
you
can.
can. Okay.
Okay.
Bye bye.
Bye-bye.